Let's do one more example of finding the radius of convergence and interval of convergence for a given power series. In this example, we have nx plus 2 to the n over 3 to the n plus 1. So like before, we'll apply the ratio test. In this case, notice we have x plus 2 to the n. So at an plus 1, we'll have n plus 1, x plus 2 to the n plus 1, over 3 to the n plus 1 plus 1, so it'll be 3 to the n plus 2. And then the reciprocal of that would be 3 to the n plus 1 over 3 to the, or nx plus 2 to the n. Okay, so let's simplify the 3's here. We can divide. 3 to the n plus 1 will divide with 3 to the n plus 1 here, so I'll have one more factor of 3 left over downstairs. X to the n divides, or sorry, x plus 2 to the n divides with x plus 2 to the n up here. Now let's see what remains. So I've got n plus 1 over n. I have the absolute value of x plus 2 over 3. Keep in mind that I'm leaving the absolute values around the expression that has the variable x. 3, of course, is a positive constant, so it doesn't require an absolute value. And then again, as we take n to infinity, we'll take the limit as n goes to infinity of this part here. We can simplify this. This is 1 plus 1 over n. And that'll, of course go to 1. So here we're just left with the absolute value of x plus 2 over 3. And for the ratio test, we want to make sure that this is less than 1 for convergence. And then here finally I'll multiply the 3 over here, and that will give us the form where we can recognize the radius of convergence. In this case, notice now it's in the form x minus a less than r. So here is the radius of convergence. In this case is 3. Now let's test the endpoints to get the interval. So the interval will be all values of x satisfying this inequality. X plus 2 is less than 3 in absolute value. So we'll open that up. So it's negative 3 is less than x plus 2 is less than positive 3. Then we'll subtract the 2. So I have x is between negative 5 and 1. And keep in mind, we're going to now test the endpoints. So the next step will be to test x equals negative 5. And I'll test it by plugging x equals negative 5 back into the original series. So we got n times negative 5 plus 2 to the n over 3 to the n plus 1. Let's see how this simplifies. So we have n times negative 3 to the n over, this is, notice 3 to the n plus 1 is 3 to the n times 3. And then notice that these guys here will simplify into negative 1 to the n, right? Negative 3 divided by 3 is negative 1, and they both have a power of n. So let's write this as the sum of n times negative 1 to the n over 3. What you may notice now is that as n goes to infinity, this expression will not approach 0. So notice here that the limit as n goes to infinity of n times negative 1 to the n over 3, well, n over 3 goes to infinity, and then the negative 1 to the n is going to be alternating, so this limit doesn't exist. So it's certainly not equal to 0. So it's divergent. So therefore, we're not going to include x equals negative 5 in our interval of convergence. Let's test the other endpoint. So at x equals 1, what happens? So we'll put x equals 1 into our series. Okay, so again here we get the series n times 3 to the n over 3 to the n plus 1, so that's 3 to the n times 3. Notice now the 3 to the n's divide, and so this becomes the series n over 3. And clearly, again, for the same reason that we have over here, this is divergent by the divergence test. Because as n goes to infinity, n over 3 goes to infinity. So we see that, yeah, at x equals 1, this one is not included in our interval of convergence either. So therefore, the interval of convergence will be the open interval from negative 5 to 1.